Let's find f op g of x and g op f of x in the domain of each. That's fog and goff is what I call them, function composition. Now with function composition, look at the fog of x, f op g of x. Now what this is, that means you're going to rewrite it as, or think of it as, f of g of f of x. What that basically is, you think inside out. The inside function, which is the g of x function, it's substituted into the f function, or the outside function. So what you're really doing is, you're taking this 4x minus 3, which is going to be our g of x. We're going to take that, and we're going to substitute it into this outside function, the f function, for x, wherever x is. So in other words, instead of writing down the x, I'm going to leave a blank parentheses squared minus 7, because inside becomes our g function, so because we're putting g inside the f. G is 4x minus 3, so that's what goes in there. And then all we're going to do is just clean this up. So 4x minus 3, I'm going to do it the long way. So 4x minus 3 squared is 4x minus 3 times 4x minus 3. Don't forget to bring down that minus 7. We're going to FOIL this out. So you're going to get 16x squared minus 12x minus 12x again, and then that's a positive 9. And don't forget to bring down your minus 7. I'm going to put parentheses around that so you know what we did. Parentheses don't mean anything. I'm just showing you that 4x minus 3 times 4x minus 3 is this. Now I'm going to go ahead and combine like terms all the way across. So I have 16x squared minus 12x minus 12x is minus 24x, and then plus 9 minus 7 is plus 2. And that's what goes here. 16x squared minus 24x plus 2. 16x squared minus 24x plus 2. Now let's go ahead and find the domain. Now when you find the domain, there's actually two things you have to find, because the inside function takes precedence. Because you're taking that and substituting it inside the other function, the outside function. So there could be some x values here that don't exist inside the g. And so let's just graph everything. So we want to graph the g of x function, which is 4x minus 3. And hopefully you'll know that's a line. And hopefully you know that lines in this case go forever left or right. The only time they don't is vertical lines. So in this case, the g of x function, as a colon, has the domain of negative infinity to positive infinity. Now we found the entire fog function, so let's go ahead and graph that one. And hopefully you already know pretty much how it looks. Hopefully you know it's a parabola, otherwise a big old U. And so for this function, we have a U, and it goes forever to the left and forever to the right. So the domain of that is negative infinity to positive infinity also. Now, the actual domain of fog, f op g of x, is what these two have in common. And as you can tell, they have the same thing in common because they're the exact same thing. So it's negative infinity to positive infinity. And that's it. That's what you're doing. So now we're going to do goff of x. Now when you do goff of x, that means we're going to take, let's just do it all. We're going to find g of f of x. That means that this f of x goes inside the g function. Let's go ahead and write down the f of x function down here so we can all see it. The f of x function was x squared minus 7. And g of x was 4x minus 3. So this time we're taking the f, this function, and we're going to substitute it into the g function for the x. So what that means is, I'm going to do it all step by step. We take the f of x, which is x squared minus 7, and we're going to substitute that into the g function. The g function, or we're taking the f function, which is x squared minus 7, and we're going to throw it into the g. You can actually get lost in this notation. That's why I don't really like showing this too much, because people do get lost in it. So you're going to take the g function, which is 4x minus 3. I'm leaving out the x, and I'm going to substitute the x squared minus 7 into it. Now let me show you what I really like to do, because I think this is actually better. You ready for this? I'm going to do what I did last example. We're going to take the x squared minus 7 and just throw it in there for the x. So I have 4 empty parentheses minus 3. So what goes in place of the x? It's the x squared minus 7. See that? F inside of g. F inside of g. And then clean it up. 4x squared minus 28 minus 3. 4x squared minus 31. And that's our GOF. What is it? 4x minus 21? 4x minus 31. 4x squared minus 31. So once again, we have to find, since it is GOF, we got to find the domain of f of x first. And f of x is x squared minus 7. Hopefully you know that's a parabola. Big O-U. And it goes forever to the left and forever to the right. So its domain is negative infinity to positive infinity. And then I need to consider this function. And hopefully you already know that it's also a parabola. 4x squared minus 31. And its domain is also negative infinity to positive infinity. And what do they have in common? Well, everything. I wrote these in the wrong places, but that's okay. This should be 4x squared minus 31. And the domain down here is negative infinity to positive infinity. And that's it. So make sure when you find the domain, you do the inside function, then you do the whole function. Inside a function, the whole function. And see what they have in common. On this example, we're given two functions. F of x is 7x plus 1, and g of x is the square root of x. We're asked to find fog and GOF, function composition, f of g of x, and g of f of x in the domain of each. So start the fog of x. I'm going to do this the way I prefer to do this. That's the same as f of g of x. That means you're going to take the g of x and you're going to substitute it into the f function. So we're taking this g of x function and we're going to replace it for the x in the f of x function, which means instead of writing down 7x plus 1, instead of the x, we're going to write what the function g of x is, which is the square root of x. And you're pretty much done. I can't simplify that any. And so that's what goes here. Now, when we do the domain, you have to look at the inside function first. So the domain of the inside function, which is the square root of x, let me erase these lines out. The square root of x, I recommend going to your calculator and typing in second square root of x and graphing it. Now what's going on, it looks like it's going from to left from 0 all the way to infinity. The only question is the 0 included or not? So one quick way to find out is hit trace 0, enter, and if you get an answer, 0 is an answer, that means it is included, so use a bracket. If you got nothing like this, like -1, enter, you don't see anything. That means -1 is not included, but 0, we saw an answer. But we also have to check this function, the one we found for f of g. So let's do 7 second square root x, make sure you get out of there, plus 1, and plus 1's on the outside of the square root. And it looks very similar. Let's just check to make sure. Well, the only thing we have to look at really is the fact that the x is underneath the square root. And another thing you can do, you have to realize that you can take the square root of any positive number and 0. So x must be greater than or equal to 0. And it's verified once again. If you hit trace 0, enter, we get an answer. And if you do like negative 0.0001, we don't get an answer. It's kind of a quick way to check it. So what that means is the domain of this function is also 0 to infinity. So the domain of fog is what these two functions have in common. Since they're the exact same thing, it's pretty obvious that they have each other in common, 0 to infinity. Now we're going to go the other direction. We're going to do g of f of x. Using the same reasoning, I'm going to write down my two functions again. F of x is 7x plus 1, and g of x is the square root of x. Let's just make sure. So this time we're going to take the f function and substitute it into the g. So g is the square root of x, but I'm not going to write down the x because I'm taking this whole function and I'm putting it in place of the x into the g function. So it's the square root of 7x plus 1. So that's what we have here for now. Well, for always. Now we have to find the domain. Now, on the domain of Goff, we got to do the inside function first. Now the inside function is 7x plus 1. So the domain of 7x plus 1 is a line. Its graph is a line, goes from negative infinity to positive infinity, left to right. That's what we're looking at. But we also have to look at the domain of this function. Now this one's going to be a little bit more complicated to do in a calculator. I'm just going to erase this out a little bit. And we're looking at the domain of the square root of 7x plus 1. So second square root 7x plus 1. Now all that's under the square root graph. Now, it looks like that it may be getting to 0. Let's find out. If we hit trace 0, enter, we do get an answer. Let's just do like negative 0.0001. We get an answer also. Uh-oh. So 0 isn't the only place where it stops or begins from the left. That means we gotta look at something else. We have to look at the domain of square root of 7x plus 1, which is what we're trying to find. We already know that you can only take the square roots of numbers that are greater than 0 or equal to 0, which means that 7x plus 1 must be greater than or equal to 0. So we're going to solve this equation. Subtract 1 from both sides and divide by 7. So what that's telling us is, if we go back to our calculator, if we type in trace negative 1 divided by 7, enter, we get an answer. But if you do anything less than that, we won't. Let's just do like negative 1. We won't get an answer. So that's telling me is that the domain of this function, it goes from negative 1/7 to infinity. Now, the true domain of Goff is what this and this have in common. Well, this has everything, and this only goes from negative 1/7 to infinity, so what they have in common is this interval. Because that's definitely inside of that one. And that's it. For this example, we're given f of x is x squared plus 3, g of x is square root of 7 minus x. We're going to find fog and Goff and the domain of each. So when we do fog of x, this is function composition, in case you're wondering, f of g of x. We're going to find f of g of x. I'm not sure what that is, I just wrote. It's like the third video in the last 10 minutes I've done over this. F of g of x. And what that basically means is you're going to take this g of x function and put it into the f function. So take this whole function and substitute it into the x. So instead of writing down x squared, we're going to write blank squared plus 3, and that blank is the inside function, g of x, because we're going inside, out. So g of x goes inside the outside function, and g of x is the square root of 7 minus x. Let me erase this off so you can see a little bit better. That's what we're doing. And then clean this up a little bit. The good thing about square roots and squares is there's a 2 on the outside here, if you don't see a number, And that 2 cancels with that 2, leaving just 7 minus x. And then bring down plus 3. And then 7 plus 3 is 10, which is 10 minus x, or negative x plus 10. Now to find the domain, we have to find the domain of two things. We got to find the domain of the inside function and the domain of fog of x, which we already found. So let's go ahead and find the domain of g of x. The domain g of x. Now since this is square root of 7 minus x, let's just go ahead and graph it. And you'll see a sideways, half of a sideways parabola on the side. And that's going forever to the left, but to the right it's going to 7. How do I know that? Basically because when I take this square root of 7 minus x, I know that the radicand, the expression under the square root, has to be greater than 0 or could be equal to 0. So when I saw this, I like to add x to both sides. I like to flip it around. When I flip it around, make sure the sign points towards the x. So what that's saying is what this graph verifies. It's going forever to the left, and it's going right to 7. So the domain of the inside function is negative infinity to positive 7. Bracket, because the 7 is included. If you do trace 7, enter, you'll see we get an answer. If I do 7.1, I don't get an answer. Kind of a quick check. Now, I also need to find the domain of fog, which is, for this equation, 10 minus x, this expression, this function. So 10 minus x, if you look at the graph, it's a line. And we hopefully know that we know the domain of lines, for the most part, are always negative infinity to positive infinity. So the true domain of fog is what this and this have in common. Well, that has everything, and this goes from negative infinity to positive 7. And so, since that's everything, we only have to look at this, because this is what's common to this. It's where they intersect if you actually were to draw the two lines out. See, if you want to do like a number line graph, this would go forever, both directions. And then negative infinity and negative 7 would stop, like, somewhere around there, but going forever that direction. And so what they have in common is this region right there, negative infinity to negative 7. And now we're going to do, oh gosh, I'm changing my color. Goff of x. Let me draw a line so you see we're doing something else. So that's g of alpha of x. And when we do this, we're going to take the inside function and substitute into the g. Well, this is our inside function, x squared plus 3, and it's going to go inside the g. Which means we're going to take the g, which is the square root of 7 minus, but then we're not going to do x. We're going to do empty parentheses, because f is going to go inside there. F is x squared plus 3. Take the whole thing, substitute in for the x. And then we just clean it up. And 7 minus 3 is 4, and then minus x squared. So we get 4 minus x squared. Do you see that? And if you want to see an extra step, you do 7 minus x squared minus 3. Now you can see it, hopefully. And once again, we got two functions to consider. The inside function, which is f of x, this is for the domain. F of x is x squared plus 3. So I'm just going to come over here. And we're going to look at the domain of this function first, because it's the inside function, and actually takes precedence. X squared plus 3, it's going to be a parabola, goes forever to the left, forever to the right. which is always good. So whatever we get over here is going to be the domain of our true. It's going to be a true domain. So let's go ahead and find the domain of this function. And so let's just type it in. And this may be a different type of function that you've seen. And it just goes from, if you look at it, it looks like it's going from -2 to +2, which it is. Now I use parentheses. I shouldn't put anything there, because we got to find out if those numbers are included. Quick check, trace -2, enter. We got an answer, 2, enter. So they actually are included. Now if you want to do it by hand, you can always take that 4 minus x squared and recognize that it has to be greater than or equal to 0. And I like to add x squared to both sides because I don't like the negative sign. So we get 4 greater than or equal to x squared. I'm going to flip it all around. I promise you it's easier to look at the graph, because what I'm doing right here is going to be a long way. So if you don't want to watch this video anymore and just recognize the true domain of Goff is what these two have in common, well, that's everything, and that's just -2 to 2, so that's what they have in common, -2 to 2. That's the answer. But if you want to see how you can get this part by hand, continue watching the video. So I know the radican's got to be greater than or equal to 0. What I can do now is to subtract 4 from both sides to make it equal to 0. And I can factor or use a quadratic formula. And then I need to find critical values, so I set each of those equal to 0. And you solve, you get x equals 2, x equals -2. I warned you, I would have stopped this a long time ago, but I have to keep on going. Some people aren't allowed to use calculators or don't want to. So now I'm going to look at a number line. So I have -2 and +2. And I'm looking at this equation. So when I substitute a number over here, like a -3, for example, I get -3 squared is 9, 9 minus 4 is 5. I get a positive answer. So that's all I care about. So I get positive over here. In between, if I throw in like a 0, 0 squared is 0, 0 minus 4 is a negative. So that's a negative. And if I throw in like a 3 over here, 3 squared is 9, 9 minus 4 is a positive value. And I already know that at -2 and 2 they exist. I should have put that positive down here. So -2 and 2 are part of the solution because it's where it's equal to 0. So less than 0 is where it's negative. So it's negative from -2 to 2, both of those included. That's the long way. So I would have stopped way up here when I did the calculator. Just some things to consider. On this example, you're actually given the fact that h of x is equal to function composition of f of g of x. So what we're saying is f of g of x is actually equal to 8x plus 7 cubed. That handwriting is kind of terrible, isn't it? Okay. Now, when you see alpha of g of x, that's the same as alpha of g of x. And where that comes from, it comes from inside out. G of x is the inside function, and alpha of x is going to be the outside function. So what you want to do is look for the inside function first. The inside function is g of x. Do you see an inside function when you look at this? Well, I do. I see an 8x plus 7. Now here's the beauty of what I'm using to do this. When I realize that my inside function is 8x plus 7, because I can see it's inside of something cubed, if I take that out, what's left over is my outside function, which is the f of x. So it's something cubed. Now, what we need is a variable, because this is all substitution. Fog and Goff is substitution. And what variable are we going to use? Well, it's what we have in our notation, x. So our f of x is x cubed. So whatever you take out is replaced with an x. This is a backwards Fog and Goff problem, and I really can't explain it any easier than that. So take it for what it is.